Welcome to the lecture for research methods. I'll be talking about validity. Although chapter 2 in your text also addresses some ethical issues, I'll reserve discussing that until we cover ethics in week 6. So, focusing on validity. What is it, right? It's about truth, right? And we talk about validity and truth in science. We talk about big T truth and little t truth, right? And we make a distinction because there's kind of this recognition that there might be a difference between what we can observe, which is little t truth, and what truly is big T truth, right? So in science, we do our best to account for the things that might detract from our finding little t truth in hopes of shedding some light on big T truth, right? So we try to eliminate any kind of distractions, confusions, to get as close to possible as to what we can know. But usually there's some goal beyond that, some questions that we can't find answers to, like the meaning of life. Why are people here? Why are people different, right? Those are questions that, kind of these philosophical questions, that science can help inform, and they can inform them by focusing on little t truth and getting eliminating biases and preconceived ideas as much as possible. But ultimately, the science falls short of the big T truth. But we do the best we can with little t in hopes of, again, shedding light on the fundamental truths about human experience. That's what validity is about both of those, really, about trying to find out what really is. But our focus is on finding out, well, of what we can see, what really is there, right out there right now. Okay, and two main types of validity that we'll talk about in terms of science and experiments. Internal validity is about the truth of cause and effect relationships. And really, internal validity only technically applies to experiments, but the term is often also applied to correlational studies as well. And in that context, it's usually to indicate the truth of some sort of associative relationship. Are these two variables really related? But technically, it should only be applied to cause and effect relationships. Does A really cause B? Are differences in B because of differences in A, and not just correlated, right? And then external validity is about the generalizability of the truth you find. And external validity can be applied to a variety of studies, but in the context of an experiment, so the truth you find about a cause and effect relationship, how generalizable, how much does that apply to other situations, other individuals, than the ones that you studied? For anything that's not exactly like what you studied to find some relationship, can the conclusions you drew about that, the cause and effect, do those conclusions hold true for other people, other situations? Okay. So, looking at internal validity, to establish the truth of a cause and effect relationship in an experiment, you need to demonstrate two things. One, that there's a difference in the dependent variable, right? Because the dependent variable is the thing you're looking at being affected, the result, the effect. So the thing being affected needs to be different at different levels of the independent variable. When we say different levels of the independent variable, that typically is represented by different groups of people, right? And it can be two really different groups where one group of people got a treatment and the other group didn't get a treatment or got a placebo, right? So they had two different experiences. And each level of experience, or each type of experience, is a level of the independent variable. The independent variable being treatment. Yes treatment, no treatment, or 0 milligrams of the drug versus 10 milligrams of the drug. Right, those are different levels of the independent variable. But you might also just have one group of people, but do kind of a pre-post design, right? So where you're measuring them on the dependent variable before you do something to them, before you give them a drug, and then measuring the dependent variable again after you give them the drug. Same group of people, but it's pre-post. But generally, in some way, you're comparing people who haven't been exposed to the causative, the agent, the independent variable, to people who have been exposed to it. Sometimes it's two different groups, sometimes it's one group of people, and you're just doing pre-post. Right? but there's supposed to be some difference in the dependent variable depending on if something's been done to them or not, right? Depending on level of the independent variable. And when we compare two groups on any variable, it's pretty unlikely that the two groups will score exactly the same, regardless of whether or not you did anything differently to the two groups, right? We get some sample drawn from the population, we divide them into two groups, and we measure depression in both groups. Not real likely that if we use, kind of a fine-tuned measure of depression, not real likely that we'll have exactly the same average, right? One group might be a score on some scale that's 1 to 40, 20.1. The other group might be 22.3. Or they might be 20.1 and 20.2. Still, those aren't the same. There's a difference, right? They have different levels of depression, even though maybe we haven't treated them at all yet. We just got these two groups. But they're not exactly the same because there's random variability, right? And some variability between groups is expected due to individual variability on the dependent variable, right? And this is where statistics come in. Right? They help us estimate the probability of finding a group difference the size of X, a group, if the group difference is, 5 points or 10 points, whatever. What's the probability of finding a difference that size if the two groups were not treated differently, i.e., what if they came from the same population? So if we didn't manipulate anything and we found a difference this big, how likely is it to have found that? Right? And that's what statistics come in to tell us, is this difference something we would expect if we hadn't done anything to them? And if it's not, then then it's a reliable difference. It's a statistically significant difference. We'll talk more on that later when we come to talking about data analysis. And the other big thing for internal validity is being able to rule out alternative plausible hypotheses. Right? So let's say the two groups are different, and our stats say that it's a reliable difference. Right? So there is something probably, because statistics is a probabilistic mathematics, there's something different about the two groups in truth. Right? Now we have to figure out, or when we're designing it, we need to take steps to make sure that it's safe to conclude that this difference is caused by what we did to them, i.e. the independent variable. Right? So why else might the groups be different? Right? If we've already used statistics to account for individual variability, what other reasons might these groups be different other than the thing that we tried to do to make them different? Right? We treated one group, we didn't treat the other. So we hope they're different, and we want that difference to be due to our treatment and not due to anything else. So one explanation for a group difference is that, it could be that the groups were different before you did anything to them, before the independent variable was introduced, right? So, if I got a sample of people for a study in depression, and I said, okay, who wants to be in my study? Who wants treatment? Who doesn't? If you want treatment, you're in the treatment group. If you don't want treatment, you're in the non-treatment group. I'll let people pick. I might end up with people who are more depressed in the treatment group. People who aren't really that depressed, like, no, I don't really need treatment, but I'll take the $50 to be in the study. Sure. And then I get to have this group difference before I even started treatment. Right? So there may be pre-existing group differences, and the most common way to deal with this in an experiment is to use random assignment. Right? And the goal of random assignment is to create equivalent groups. Right? If you've got a handful of severely depressed people in your overall sample, right? I went out and just got volunteers for a study, and I got 100 people. Right? And there's a handful of people in that sample that are severely depressed. Random assignment should result in an equal number of severely depressed folks being put in the treatment group and in the non-treatment group. But random assignment is random, and it doesn't guarantee equal numbers. It doesn't guarantee equivalent groups. Here we're relying on probability. And one thing that we know about probability is that predictions based on probabilistic models are more accurate with more trials. Right? So if I have a really large sample and I use random assignment, I'm pretty confident that the groups are approximately equal. If I have a sample of 10 people and I use random assignment, it may not be that different, right? Because I need lots of trials for the randomization procedure to result in equivalence. One way to illustrate that, think about roulette, right? If we take out that, I think there's a green thing on the wheel, right? But generally most of them are red or black. And so eliminating the green space in the wheel, it's about a 50-50 chance that the ball on the roulette wheel is going to land on red or black. And if you try to go to the casino and try to make some money using the hypothesis that, well, the ball landed on red last time, it should be black the next time, right? Because, hey, it's 50-50. And out of these two trials, there's already been one red, the next one should be black. You're going to lose a lot of money. Even if you do 10, and 10 times it's been red 10 times in a row, you think, okay, it should be black next. Might be, might not be. That's how randomness works, and that's how casinos make a lot of money, relying on our misunderstanding of probability. Okay. But again, with large samples, random assignment tends to make them more equivalent. Not necessarily equivalent, but more equivalent. So we're more confident that any kind of difference that we find after doing our independent variable thing is due to the independent variable. But this should kind of bring home the point that internal validity isn't an all or none matter. Oh, it has internal validity. No, it doesn't. It's a matter of degree. To what degree are you confident that the conclusions you drew are accurate, are true about the cause and effect relationship? And there are a lot of things that affect that estimation. Few of which are really fully quantifiable. Okay. But random assignment helps. Alternative explanations for a group difference also abound when the groups, so assuming they're equal now, assuming random assignment has worked, now we've got equal groups before doing anything, now we still might have a difference if those two groups experience different things other than the independent variable, right? And it could be differences in their environment, right? So maybe I'm running a study with some treatment study, and I have the treatment folks meeting in room A and the control group meeting in room B, but room A happens to be really hot and room B happens to be really cold, right? Now my groups differ in more than just my treatment. There's also this temperature difference, which I'm not interested in temperature. It's this extraneous factor. But if it's systematically different across groups, it's now a confound. And when there's a confound, that's something that's systematically different across groups other than the independent variable. Now I don't know if the difference is because of my independent variable or if it's because of this confound. I can't. They're entangled, and I can't figure things out. So we try to eliminate those. Right? It could be, an experimenter smiles and is more friendly to one group than the other. Right? They're friendlier to the treatment group because they're kind of hoping it works, and they're kind of frowning at the control group. Or it could be differences that occur kind of within the individuals. It could be things where the treatment group maybe figures out that they are the treatment group, and then their responding on the dependent variable is influenced by some internal desire to either please or thwart the experimenter. Right, so to limit these explanations, these alternative plausible hypotheses, you treat people at different levels of the independent variable, these different groups, as similarly as possible. Right? Try to you exert experimental control to limit anything that they might do, take away their cell phone so that, in one group, somebody's cell phone went off and they started talking, and it was really distracting the whole group, and it affected the scores in the DV, right? Or whatever. You try to make their experiences as similar as possible, since the only thing that differs is the independent variable. And then you also typically try to disguise your hypothesis, because if people figure out what you're looking for, depending on what kind of people you're working with, usually though they try to help you, and not even consciously, but it's something we've discovered in other research, that if you let people know what you expect to happen, they'll try to help you find what you're looking for people that are generally helpful. So typically we have participants blind to what condition they're in, if possible, and also sometimes it's important to also keep the experimenters blind to what condition they're in, to keep the experimenter from smiling at one group and not smiling at the other. Right? And again, we'll talk more about that when we get to talking about methods stuff. But we exert experimental controls, try to limit these alternative plausible hypotheses. And then the other big thing is construct validity, right? Because in behavioral science, the things that we're most interested in, the really cool stuff, are typically unobservable entities, right? Intelligence, sadness, love. These are abstract ideas. They're constructs, and we call them constructs because we construct these ideas or abstractions based on our experiences, right? We do these things where we hug and we do things for people, and we miss people when we feel bad when people aren't there, and we kind of call this experience love. right? But you can't see love, you can't touch love, you can't directly measure love. So it's a construct, something we've constructed. And because they're unobservable, we've got to rely on indicators of the presence or level of a construct when doing our science, right? So for love, maybe you could operationalize it, you could define it as how often a parent hugs their child, right? And then, so construct validity, we have a good idea what a construct is. Construct validity refers to the extent to which the observable physical indicators that we use to measure or represent a construct accurately reflect that construct, right? So do the differences in number of hugs really indicate differences in amount of love? If so, I may have that measure may have good construct validity. And there's lots of other questions to ask when determining if something has good construct validity, but again, we'll get into that later. I just want you to understand the basic idea right now. Most often, when we're talking about construct validity, we're talking about measuring our dependent variable, right? So are the things we're measuring, do they have good construct validity? Because we often measure behaviors to represent constructs, right? So if we're looking at changes in aggression, sadness, attachment, security, is the way that we choose to operationalize these variables a valid and accurate reflection of the construct? Okay, and then something we maybe don't think about as much is this also applies to our manipulation of the independent variable, right? And in some instances, the independent variable is not a construct, right? If you're doing a drug study, it's not. It's a physical, observable thing. You know how much of the drug is the drug. It's not an idea of something, right? But many times, our independent variables are constructs, right? So cognitive therapy, that is a construct. There's an idea about what cognitive therapy is. Empathy in a counseling relationship, right? We think, okay, I think when empathy is present, this will happen. There'll be less symptoms. When empathy is absent, there'll be more symptoms. So I think empathy is this variable, right? But can you touch empathy? Can you show me empathy? Right? Well, you can show me behaviors that are maybe indicators of empathy, but it's another construct, right? So is the way that you choose to operationalize empathy, for example, an accurate reflection of the construct? If not, then when we find a group difference or fail to find a group difference, then we're less able to say that empathy caused or didn't cause a change in symptoms, right? We could say, if I operationalized it as, well, empathy is nodding my head when the client talks. I could say, therapists that nodded their heads when the clients talked reported a decrease in symptoms among clients. Right? But usually we're not interested in those specific behaviors. We're more interested in the broader constructs. And if you want to draw conclusions about broad constructs, you need to pay attention to how you're operationalizing them and choosing them wisely to make sure that the way you're operationalizing it does reflect what you're trying to talk about and draw conclusions about. Okay. All right. So internal validity is about, is the cause and effect relationship true? If I say that it did cause an effect, or if I say it didn't, how confident can I be that I'm right? External validity, as I said before, is a little different. It's about once I make that decision, I draw some conclusion based on some set of people doing some set of things at a certain point in time. Is that conclusion true for other people, other situations, other times? Right. Now, the first requirement for external validity is internal validity, right? If you're not sure if your conclusion about the cause-effect relationship is true, then you can't possibly generalize those conclusions to anyone in any situation at any time, right? So all things that affect internal validity also affect external validity. Okay? So internal validity is a prerequisite. It's necessary for external validity, but it's not sufficient. And also, somewhat ironically, there's a tension between the two. Right? It's not as simple as, well, if we increase internal validity, we'll get good external validity. In fact, when we exert efforts to increase internal validity, sometimes it results in a decrease in external validity. And vice versa. If we make choices to increase external validity, it may detract from our internal validity. Right? Because generally, the more we control, the more control we exert in an experiment, to try to account for plausible rival hypotheses, the less the experiences of our participants look like what happens in the real world. Right? For example, if you're doing a treatment study with some therapy, you say, okay, well, I want to make sure that everybody gets the same type of therapy in my study, so that when I say, that this therapy works, or that it doesn't work, that I've got a good idea of what this therapy is. So maybe I'll use a treatment manual. I'll have a manualized therapy. Right, so every practitioner who does therapy in my study has to learn this manual and go step by step, session 1, session 2, session 3, here are the goals now, here are the techniques, yada, yada, yada. That way I can be really sure that, okay, yes, doing it this way does work. And the question is, well, now you found that doing it this way does work, getting therapy like that, how similar is that to therapy in the real world? How many other clients, when they go to get therapy, even if it's the same type of therapy, it's CBT, will they get a manualized treatment that's exactly like what you got in that study? And probably not. So the question again, it's not all or none. It's how different is the experience in these other situations than from the experience in the study. Okay. It's important to kind of keep in mind, though, that when we talk about external validity, it's often talked about in terms of generalizability of the findings. But this isn't quite accurate, right? It's not about saying, participants in this type of therapy will experience a decrease in symptoms by 20%, because that's what we found in the study. Right? It's not that specific. It's more, it's broader. It's like this type of therapy reduces symptoms. And to really keep science moving coherently, an even higher level of abstraction should be employed. Think about how the findings of the study support or fail to support a theory about psychopathology. And the question then becomes, how well does the theory generalize? Right? For whom, when, and where is it applicable? Okay. So we're more concerned with the generalizability of conclusions and beyond that even, the generalizability of a theory that the study is testing. That's at least in my mind, in the mind of many researchers, more important than doing a study that where it looks like everybody in your study and it accounts for all these different things. Because if you do that, it's going to make your internal validity crappish. In general, though, when you're evaluating a study's external validity, right, and especially when you're focused on the generalizability of the conclusions of the study, not necessarily of a theory, but of the study, you need to consider how representative the people or experiences in the study are of the people and experiences you want to generalize to. Right? It's important here to note that external validity is dependent on the goals of the person evaluating the study. Right? Who or what you want to generalize, do you want to generalize to? If you do a study looking at aggression in kids, the conclusions may not generalize to adults. But if you're interested in aggression in kids, you're not interested in adults, you may not care, right? So it's like, oh, you have poor external validity, it doesn't apply to adults. Well, I don't care, it's a study about kids. Right? So to some extent, external validity is in the eye of the beholder. Who do you want these conclusions to apply to? In what situations are you trying to generalize to? Right? So it's a bit subjective. Most often, when we read and hear about discussions of external validity, you hear people talking about the composition of the sample. Right? Is the sample representative of the population? And again, it depends on what population you're talking about. Right? The population isn't all people. It's not even all people in America, usually. Maybe your population is depressed women of moderate SES living in the western United States. Right? So it depends. So when choosing a sample, that means you need to keep in mind, what population are you interested in learning about? What population do you want to generalize to? And then construct a sample that will generalize to that population. And sometimes you don't care at all. You just want to see, can this thing happen? Right? Is it possible for somebody's symptoms of depression to be treated to go away? Right? And we don't care if the people in our study look like anybody else. We just want to know, is it possible at all? And once we know it's possible, then we can do other studies to see, is it possible with different types of people? Right? Another aspect that isn't often considered when talking about external validity is that any given study occurs at a precise point in time. Right? So the findings about what people are like at that time may not generalize to what people are like at some point in the future, right? For example, paranoia about traveling with individuals of apparent Middle Eastern descent. If somebody, it looks like they're Middle Eastern descent, people get on planes now, and there's a heightened paranoia in the United States, and that's different from what it was pre 9/11, right? So there are these kind of historical factors that cause changes in people. And you think, what other things related to psychopathology might be different? So we found this. This is what people are like. This improves depression. This worsens depression. Is that still true? Maybe. Right? We can also talk about the representativeness of the independent variable. Right? If we're doing a treatment study and you conclude that CBT works, that's kind of what I was talking about earlier. Is the therapy, the CBT that you used in your study, similar to how it would be received in the real world? Right? And then last, we can talk about the representativeness of the dependent variable. Right? So if you showed changes in depression using the Beck Depression Inventory, second edition, how well do those differences reflect changes in depression in all people? So now you can probably hear, kind of feel, hopefully, there's some overlap here with construct validity. Right? Your construct validity will influence your external validity above and beyond its effects, influences on internal validity. Okay. So summing up, internal validity is about the truth of a causal relationship. External validity is about whether or not the conclusions hold true outside the context of the study. Okay, in context, broadly defined. And as I already touched on about that tension between internal and external validity, there are many articles and book chapters written about this tension, and ongoing debates about finding some happy medium. You know, one side says, "Oh, too little internal validity." The other side shouts, "Too little external validity." But because external validity is dependent on internal validity, the most logical course, in my opinion, based on reading other people's opinions, who are much smarter than I am, is to maximize internal validity within individual studies. Right? Then we don't forget about external validity. It is important, but we pursue external validity by conducting more studies. So if you find something, make sure that you're confident that A caused B, then replicate that study with different types of people, with different types of experiences, with a slightly different way of measuring your dependent variable, with a different way of manipulating the independent variable. Right? So don't try to get all your external validity met in one study. Focus on internal validity. Make sure you're confident about the cause and effect, and then move forward. Either there was no effect or there was. Now, if we do it in another group, is there effect there or not? Okay, that would be my recommendation. Lastly, just kind of a heads up, more to come. As we start talking about designing a study, we'll repeatedly come back to issues of internal validity and external validity, and we'll talk about how the choices we're faced with in terms of composing our sample, choosing how we're going to manipulate the independent variable, how we're going to measure the dependent variable, how we're going to analyze, how we would analyze the data. We're going to come back to these and be faced with the impact of these choices on the validity of the conclusions we could draw from our study. Okay, so this was kind of a broad introduction to internal and external validity, but you'll hear those terms over and over again, and that's kind of my goal for you, one of my major goals for you in this course is to know how the decisions you make when designing a study influence validity. And when you understand that, then when reading studies, you'll know, okay, well, they did this, this, and this, and that influences the internal validity, and it influences the external validity. All right, that's all for now. Take care.